Okay, next up is Fabrice, and he's going to talk about his experience of building the Lightning Network.
Okay, so good morning. I'm Fabrice Drouin from ACINQ, and I'll talk about what we've learned actually bootstrapping the Lightning Network on mainnet. So all of you know about the Lightning Network, so I'll resume how it works very quickly. So basically, you had first payment channels that appeared in, let's say, 2011 and were improved in 2013, but there was a problem that was described before, that you had to open a channel to everyone you wanted to pay. So it was not very scalable, and it was never widely used. And then there were several proposals for better payment channels, which eventually led to the Lightning Network paper in 2015, and that's what we've implemented. Lightning channels are bidirectional. You can pay and you can receive money. There's one Bitcoin transaction to open channels, one Bitcoin transaction to close channels, but everything else happens off-chain. So there can be lots of updates and you don't see them. And the big thing about Lightning is the multi-hop payments. If you can find a route to someone, you can pay them. You don't have to open channels to everyone you want to pay. That's the thing that is really special about Lightning. And you can think of Lightning or other layer 2 protocols are ways to update transactions that are valid but are not published. So it's like your state basically is a set of transactions that you could publish, but you don't publish. And there's one issue that was described before. It's how do you invalidate an old state? So there's a penalty transaction in Lightning. If you publish an old state, you lose everything. That's how you prevent people from publishing an old state. So this is basically what it looks like. You have a funding transaction on the blockchain. Then you exchange messages to update this transaction. And these messages are private to the two parties in the channel. Nobody else is supposed to see them. And this happens off-chain. And when you're happy with the state of your transaction, you publish a final closing transaction back to the blockchain. So on the blockchain, you see the first one, the funding transaction, and the last one, the closing transaction. And everything else happens off-chain. And this is basically what it looks like from a user's point of view. You have QR code that includes an amount, a destination, and a payment hash. The payment hash is what is part of the HTLC payment system used in Lightning. So you see a payment hash and destination. Your wallet will compute a route to the destination and send messages along the route. It reaches the destination, it sees its own payment request, it will send back the pre-image, and you've bought something on Lightning. There's something that I think is very special about Lightning in the crypto world. It's an open source project. It's not driven by a specific company or a specific group. And it's an RFC-like project. The specifications, the Lightning specifications, are low level, but they're fairly detailed, and they include test vectors. So if you go to the specifications and read them, you can start implementing your own Lightning node fairly quickly. There are 3 implementations now, but I know there's a team in Japan that is working on one. Maybe another implementation in the works somewhere. It's really different from other projects in crypto that are very often driven by a specific company, and this is basically, it doesn't belong to anyone. You can start implementing your own Lightning node, just reading the specs and looking at the test vectors. Okay, this is tongue-in-cheek, but it's one of the smartest and friendliest communities in cryptos, and I truly believe this. There's no drama in Lightning. It's very friendly and work-focused. Today you have three implementations: C Lightning by Blockstream, LND by Lightning Labs, and Eclair by us, and they're very different. It's not modifications of the same code base. They're completely different implementations with very different development stacks. You have one in C, one in Go, and one in Scala. And yet you have lots of people building lots of tools on top of Lightning, explorers, wallets. There's Satoshi's Place. Who's heard of Satoshi's Place? Okay, so it's. I thought of including a screenshot, and I did not because it is absolutely not safe for work now. But it's a very interesting concept because Satoshi's Place sells 1 pixel for 1 Satoshi. So you can buy instantly 1 pixel that you can draw for 1 Satoshi. 1 Satoshi is 1/100th of a cent. As far as I know, there is nothing that enables you to buy something for 1/100th of a cent now. The financials, Visa or MasterCard will not let you do that. I don't think other cryptocurrencies will let you do that. There's always a notion of the dust limits in most cryptocurrencies. So buying things for 1/100th of a cent is instantly a truly interesting example, even though Satoshi's Place has become a bit special now. So to bootstrap Lightning, as is often done in the Bitcoin world, we went through a phase on testnet. So testnet on Bitcoin is a Bitcoin network where money has no real value. It's test money, and it's widely used to test new ideas and to deploy stuff. So the testnet phase was very positive, which means that the core specifications were validated. There were no true problems with it. We could iron out compatibility issues between the 3 implementations. We could validate, each company could validate implementation choices, and people starting developing tools on top of Lightning, like the APIs, explorers, and a few demos. So this went rather well. On the left you have an explorer on testnet, and on the right you have yours, which is a website where you pay to read articles. You pay like 1 cent or even less than a cent, and you can read stuff. So there are demos on testnet that work pretty well. But there are things that didn't work that well, and the first things we saw when we went to mainnet is that a lot of bugs went unreported because if there's no money, there's less incentive for people to report bugs. But when there's money involved, people who lose even a few pounds, a few euros, are really unhappy. So it's like putting a coin in a vending machine and you don't get what you pay for, and it makes you angry, even if it's just €1. And we saw the same. A lot of bugs that were not reported on testnet, and we were hit with them straight away on mainnet. We could see that a lot of nodes on testnet were not reliable. A lot of them were not even reachable in the first place. People forgot to open ports and everything, so you had nodes on the explorers, but you couldn't use them. A lot of them are offline most of the time, which means they cannot be used. So it was time to take the training wheels off and go to mainnet. So Reckless at last, the first company to go to mainnet was Blockstream, then Lightning Labs, and then us. And from April, every implementation was on mainnet. And the first thing people did was to buy stickers. Who bought stickers with Lightning? Okay, good. So that people bought stickers, and it worked fairly well. And you could see one of the first problems with Lightning on mainnet. It's a liquidity issue. A lot of people opened tiny channels, a few dollars, which means you could pay for cheap items, but it was more difficult to buy expensive items. And on Lightning, expensive was a hoodie or a T-shirt. You could see that you could buy 1 T-shirt, and then the channel would be depleted, and you couldn't use it again, and people had to open new channels and everything. it's harder to find routes for larger payments. So these are, I would say, issues that are being solved as the network grows and becomes more reliable. People open larger channels, and these type of issues are going away. But at the beginning, it was a bit harder to buy expensive items on Lightning. And there's also a lack of symmetry in payment capacity. What I mean is, suppose A, Alice, opens a channel with a node that is called Squeaky Clean, and B also opens a channel to Squeaky Clean. A should be able to pay B, right? Well, actually, no, because what you'll get is A will have funds on their side, B will have funds on their side, so there's no path that allows A or B to pay each other through Squeaky Clean. So there's one very short-term solution it's to use a push option when you open channels, and so you create channels with money on both sides, but it requires external setup, as in somehow Squeaky Clean knows that A has money because it was sent on-chain, for example, to Squeaky Clean, and when A opens a channel, they will have money on the other side. And one thing that will make its way into the specs, but it was too late for the current version of specs, is dual funding. Dual funding means A and B open a channel with money on both sides, right in a funding transaction. There's also the idea of re-anchoring, which means replacing the funding transaction with another transaction that could have money on both sides, but it's not ready yet. And there's also channel factories where basically you could not go back to the blockchain, but instead reuse closing transactions to reopen new channels inside a channel factory. So it's a bit more complex, but this would enable you to not go on-chain all the time. And this is actually the biggest issue we had on Lightning. It's on-chain fee management. The idea of second layer protocols on Bitcoin is that basically you have a set of Bitcoin transactions that are valid, that are publishable, but you don't publish them. And publishable means that the inputs are still, have not been spent, that the transactions are signed properly, but it also means that the fees you pay on-chain are realistic. And fees change, can change quite a lot on the Bitcoin network. I'm talking about mining fees. So for people who don't know, when you send a Bitcoin transactions, you need to include a small fee for the miners who will mine the transaction. And these fee can change a lot over time. So to make sure that your transactions are publishable, there's a mechanism in Lightning to update the fee rate that you think is valid at a given time. And when you change this too much, you publish an update and you say, okay, now I think that we should use these fee rates. And there's a problem because fee estimators are not reliable, because basically estimating fees is like guessing the future. It's basically an impossible problem. And on-chain fees can change a lot in just a few minutes. They can be multiplied or divided by 10 in just 5 minutes. So what happens is fee changes, the on-chain fees will change very quickly, and you will send an update, say, okay, now I want this. And the node you're talking to is not aware that the fees have changed a lot and will refuse your updates and close the channel. And this happens a lot on mainnet. And to the extent that up to a few weeks ago, it was the biggest operational issue we had on mainnet. People seeing a lot of channels getting closed because their fee rates were rejected by the other side. Something else to be found, I would say it's an Easter egg in the specs, but it's also linked to the way Bitcoin works. How much is 1,000 divided by 4? Okay? It's 253. So what is that? If you want to know, you can have a look at the discussions we had on the mailing list and the bug report. So basically, Lightning uses fee rate in Satoshi per kiloweight, and the weight of a transaction is linked to SegWit. It's different. It's not its size, it's something else. Most wallet estimators will give you fees in Satoshis per byte because the size of the transaction is what matters on a Bitcoin network. It's like the post office. You pay for the weight that you want to send, not the actual value in the parcel that you're trying to send. And the Bitcoin relay fees are in Satoshis per virtual byte. And what is a virtual byte? Who knows what a virtual byte is? Yeah, it's two. You didn't raise your hand, Christian. Okay, so basically, it's a funny story, but it links to it leads to 1,000 divided by 4 being 253 because 250 will not give you a transaction can be relayed on the Bitcoin networks. It's something we learned the hard way, all of us. The first ones, Blockstream, and then us and LND. So it would be really cool if there was a way to remove fee management from the Lightning protocol. And the cool thing is, even though CPFP is not usable yet, because first you have to publish a transaction to create a child that spends it and improve its fee, L2, as explained by Christian, gets rid of fee management. So that's a very good news. There's a really nice, elegant, long-term solution for this. Another thing we looked at on Lightning, and I think it's very important for users, is how to build mobile Lightning wallets. And you have two options. The remote control option, where your wallet is actually a remote control for a full node that is running somewhere else. So it's very easy to do, but it has security issues. Basically, what it means is there's an API that can talk to a node that you're running at home or in the cloud, and there are commands to send money. So it can be pretty dangerous. The other option is to have a real Lightning node on a mobile phone, and it's not that easy. First, you have an implementation issue. It's the development frameworks for iOS and Android are very limited, and you can't reuse all the tools that you have for servers. So you have to find a development framework that you can use on iOS and or Android, and it's not that easy. And you have an operational issue. A mobile node will be offline very often. And Lightning, as you saw, you need to monitor the blockchain because if the other guy is trying to cheat, you need to publish your penalty transaction, and you have a limited time window to do that. You have to validate channels. You have to be sure that the channels actually exist, that there is actually a funding transaction in the blockchain for this particular channel. And you have to synchronize your routing table. Basically, each Lightning node maintains a complete view of the network, and they use it to create payment packets to compute routes and create payment packets that descends over the network. So you need an up-to-date view of the network. It's very easy if you're online all the time because you will receive network updates from your peers, but if you're offline most of the time, how do you maintain a valid routing table? So we went with the JVM, so our node can easily run on Android, which we chose Scala. Does anybody know what Scala is, the Scala language? Yeah, good. So it's hybrid functional object-oriented language that runs on the JVM. It's like a hybrid of Java and Haskell, maybe. So basically, we can use the same code base on all operating systems, including Android, but there's a catch, because Java 8 is not available on Android, and it won't be for some time. And there are no production-ready JVMs for iOS. There are a few projects, but they're all experimental, so it's really hard to run on iOS. And there's a problem of monitoring the blockchain. So you could delegate monitoring to a third party, but it's it's really hard to do. I will explain later why, but basically it's the watchtowers that you may have heard of, but they have not been implemented yet because they're not practical to run yet. So there are no watchtowers now. And if you say, okay, I'm going to monitor the blockchain on a device, you need a really long timeout, really long time window to publish your penalty transaction, because if you're offline for 3 days, you need to make sure that that window for publishing the penalty transaction is more than 3 days. So you would have channels with very long timeouts, maybe 1 week, which means that when you close them, you need to wait up to 1 week before you get your money back, which is not really nice. But there's something that is really cool. It's like when you're only sending money, you don't have to monitor the blockchain. It's what Christian explained with the first Spielman payment channels. If what you're doing is sending payments, then the other side has a transaction that where their balance keeps increasing. So there's no incentive for them to publish an old state. It will give them less money than the current state. So you don't have to monitor the blockchain. And if they do publish an old state, it's better for you because it gives you more money than what you have in a current state. So that problem goes away and you can be offline for weeks. And also, channels on mobile nodes don't have to be announced. They don't have to be part of the routing table. It's been the default for our wallets on Android for months. I'll come back to this later, but it has very nice properties. So send only is limited because we all would like to receive payments on mobile phone. So we are still working on it, and we may have good news for everyone very soon. But it's a very interesting one anyway, because I think it makes sense to have wallets that can only pay for things, and they're very light on the network, and you don't have to monitor the blockchain. So it's really nice. But you still need to watch for your own channels. And how do you do that on a mobile phone? You don't have a full node at your disposal. And basically what you can do is you watch the output script. That works. But it would be nice to watch for specific transaction IDs, the defending transaction IDs. And the good news is, right now we're using Electrum servers. I think Electrum is developed in Berlin. But there's a nice idea for Lightning wallets. It's called Neutrino client-side filtering. That's something we may switch to in the future. Okay, so I have 5 minutes left, so I'll pass quickly on this. Synchronizing routing tables on mobile phones was very expensive because you would ask for everything. So now there's a new protocol that lets you ask for only the items that you are actually missing. So it is much faster now on Lightning nodes, and it's going to be improved very soon with other new IDs. Watchtowers don't exist because basically if you're running Watchtower, you have to store lots of data, and you don't know when you can safely remove it, because watchtowers are not supposed to learn about what you're doing, so they don't exist yet. But if there was a way to make sure that you only need to store the last state, you could very easily implement watchtowers, and that's what you will get with L2. So you won't have to remember everything, every old state, just the last one would be enough. So we will see watchtowers with L2. So now we're going to talk about Lightning Network routing because it's a huge topic. And basically, a lot of people say that routing doesn't work because we have to solve impossible problems, blah, 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 and it's... And there are two concepts in Lightning about routing that are mixed up very often. There's a high-level concept of how did you find a route to your destination. Lightning is a peer-to-peer network, and to pay someone, you have to, it's like a graph. To pay someone, you have to find a path to the destination in the graph. And there's a low-level part of the protocol that says how is you supposed to build and sign and validate packets that forward payments. So Lightning defines precisely how you build the low-level packets, how you use source routing to build multi-op payments. But the high-level part it's not that much part of the protocol. You could use anything you want to publish what the network looks like. What is really precisely defined is once you know the route, how you create and sign the packets that will forward payments on the Lightning Network. And we use onion routing, which means that you create a packet for the destination, you add an encryption layer for the previous hop, and another one for you. So you create a packet for this one, you add an encryption layer for this node with its keys, and again another encryption layer for this node, and so on. And so when a node receives a payment, it strips its own encryption layer, it learns where it's supposed to be sent, and sends it to the next node in the route. So this guy does not know where it is in the route. It doesn't know how many hops before, how many hops after them, and it doesn't know who the final destination for the payment is. But what they know is the amounts of and the pre-image, which can help correlate payments. And nodes which are not on a payment route learn nothing. It's not like the Bitcoin blockchain where everybody knows everything. If you're not on the route, you learn nothing. So to publish and update the routing table, Lightning right now uses a very simple broadcast protocol. Basically, you broadcast information about nodes and channels to all your peers. So eventually, everyone will keep an up-to-date copy of the entire routing table. And it works very well with a few thousand nodes, but obviously, it would not work very well with 1 million nodes, which is why some people say there's a huge problem in Lightning, it will stop working very soon when you have more nodes. And no, because the problem with the routing table is you don't have to announce, every channel doesn't need to be public. Only channels for nodes that can actually relay payments. And it's not that many of them. Terminal nodes that do not relay payments but mostly pay or receive money, don't have to be announced. They don't have to be part of the routing table. There are many of them today. Every mobile node, for example, is not part of the routing table. And if you're a merchant, if you're using Lightning to receive money, you don't have to announce your channels. So mobile nodes, laptop nodes that are often offline don't have to be part of the routing table, and there could be millions of them. And it would have no impact on the size of the routing table. And right now, there are many more channels and nodes than what you see on the explorers. Because a lot of nodes, and really a lot, thousands of them, are not announced. And you can also build hidden networks of unannounced channels. If you find a way of bands to exchange information about your nodes and channels, you can very well create your own virtual private Lightning network of channels that nobody will hear about. So basically, it looks like this. It's not a view of how the Lightning network should look like or will look like or whatever. It's just a graph with these guys are what you actually see on the explorers, and the small ones are the ones you don't see, and there are many of them. And so there could be millions of them. There are thousands of them today. So which means that Lightning will not stop working in the next few weeks because we have more than a few thousand nodes, because there are already a lot of nodes, and you don't have to add them to the routing table. So we need to improve the way routing works, but it's not as bad as what a lot of people seem to think it is. So what we have now is on Lightning is basically a core protocol that works. Lightning is very much like Linux. We build things that are small and work and build on top of it. So the core protocol has been validated. There are very few interoperability issues right now. There were no major issues on mainnet, so it wasn't that reckless. There were no big thing we didn't see in testnet that caused lots of users to lose money or whatever. Testnet is a bit of a mess because a lot of nodes are not reliable and offline most of the time. And testnet, even Bitcoin testnet is really special. A few days ago, there was like 1 block every second for hours, which messes with everything. Like your payments will expire before they have been received. It's really hard to test on testnet, but it's interesting. Payment capacity is improving, so there are larger, more stable channels, and it will get better as people trust the network to open larger channels. The imbalance issue is still there, but there are short-term and long-term solutions. And the on-chain fee mismatch is being fixed, so you won't see that many channels getting closed because nodes don't agree on what on-chain beacon fees are supposed to be. So it went fairly well, I would say. We're fairly happy with how things are going on mainnet right now.
Yo. Okay, awesome. So we have time for one question. So, yep, I'll go for Chang Yu.
Thank you. That's actually quite interesting. My question is, so far, have you observed many multi-hop payments? And do you have a number, for example, percentage of that?
That's okay. The question is, it's not that easy to answer because you don't know how many hops you have when you're relaying payments. But yes, we run nodes on testnet and mainnet, and these nodes only relay payments. They don't send or receive money, and we see a lot of activity. So yes, there are lots of multi-hop payments on mainnet with at least 3 hops. But how many hops, I can't tell you, but yes.
Awesome. I can take one more question if anyone has. Yep, down here.
Hi, you said that you're encouraging different implementations of the client, which is kind of great. But what I was wondering about, very often if you're worried about security, the system is as secure as the weakest link. So if one of those implementation messes up the security, what does that mean for the whole network?
Okay, there's one thing that is really special about Lightning. Since it's not global consensus. You know, Bitcoin, for example, it's still an ongoing question. Will it be a good thing to have several Bitcoin implementations or not? And a lot of people say, actually not, because everyone needs to agree on the state of the UTXO and everything. They need to have exactly the same state at the same time. So different implementations which may have different bugs or different features would be a problem on Bitcoin. Lightning is rooted. You talk to your peers and nobody else. So if you have problems or bugs, it's fairly easy to upgrade to something else. It's very easy to close channels. So I don't think that having one weak implementation would be a huge issue, because you can just turn it off and replace it with something else without having an impact on the global network. With Bitcoin or other blockchains, it is really, really hard to stop everything and upgrade everyone. It's not the case in Lightning. And there are lots of demos that have been running different implementations, that are switching between implementations or upgrading all the time, and most of the time you don't even see it. We upgrade almost once a week on testnet, and I don't think people actually see it. So it's not as bad as on a global consensus network.
Awesome. Thank you very much for that. One more round of applause. Awesome.